Tonight, we are venturing into one of the most profound and captivating mysteries in all of science, the Fermi Paradox. It is a question that has puzzled astronomers, philosophers, and dreamers for many decades now. In a universe so remarkably vast and ancient, filled with countless billions of stars and planets stretching across unfathomable distances, where is everybody? Why have we not heard from our cosmic neighbours? Why does the universe seem so quiet, so empty, so utterly alone? Look up on a clear night, away from the glow of city lights, and you will see maybe a few thousand stars scattered across the darkness like grains of rice scattered on black velvet. But here is something quietly astonishing to consider. What you are seeing with your own eyes is just the tiniest fraction of what is actually out there in the cosmos. The observable universe stretches about 93 billion light years across. Think of it as the biggest snow globe ever imagined, except instead of snow, it is filled with galaxies. How many galaxies, you might wonder? At least 2 trillion of them, each one a vast city of stars spinning slowly in the cosmic dark. Our own Milky Way galaxy, which seems impossibly large to us here on Earth, is just one grain of sand on an infinite beach. And each of those grains contains somewhere between 100 billion and 400 billion stars. The numbers become so large they stop feeling like numbers at all and start feeling like something else entirely, like the universe's gentle way of whispering infinity to us. But let us make this a bit more personal, shall we? If you could somehow count one star every single second without stopping to eat or sleep or even blink, it would take you over 3,000 years just to count the stars in our galaxy alone. That is longer than all of recorded human history, from the ancient Egyptians to the present day. And remember, that is just our galaxy, just our own cosmic neighborhood in the vastness of space. Recently, in the past few decades, we have discovered something wonderful and transformative. Planets are everywhere throughout the universe. For most of human history, we knew of only the few worlds circling our own sun. But now we know that nearly every star we see has planets, often multiple worlds dancing around their parent stars in intricate cosmic waltzes that span millions of years. Some are gas giants, puffy and light as cosmic cotton candy, with no solid surface to stand on. Others are rocky worlds like ours, with surfaces you could theoretically walk on if you had a very good spacesuit and an excellent sense of direction. Many of these planets sit in what astronomers call the habitable zone, that gentle region around a star where temperatures are just right for water to exist as a liquid. Not too hot where water would boil away, not too cold where it would freeze solid, but just right, like the cosmic version of Goldilocks, finding the perfect bowl of porridge. In our galaxy alone, there may be tens of billions of these potentially habitable worlds, each one a possibility waiting to unfold. Imagine all those planets for a moment. Some might have oceans that have never known a single ship sailing their waters. Some might have skies that have never been looked up at by curious eyes wondering what lies beyond. The mathematics becomes almost overwhelming in its implications when you really think about it. If even a tiny fraction of these worlds developed life, if even a smaller fraction developed intelligent life, if even a microscopic portion of those became technologically advanced civilizations, the galaxy should be absolutely teeming with intelligence and activity. There should be radio signals crackling through space like cosmic conversations. There should be massive engineering projects reshaping entire solar systems. There should be spacecraft cruising between the stars like cosmic highways filled with alien commuters traveling between distant worlds. And yet, when we look out into that vast expanse with our most powerful instruments, when we listen with our most sensitive radio telescopes, when we search with our most advanced technology, we hear nothing but silence. We see no signs of cosmic construction, no alien broadcasts carrying news and entertainment across the stars, no fleets of interstellar ships heading our way to say hello. The universe appears to be a vast, empty mansion with all the lights off and no one home, echoing with silence. This silence becomes even more puzzling when you consider the element of time. The universe has been around for nearly 14 billion years, an almost incomprehensible span. Our Sun and Earth formed only about 4.5 billion years ago, making us relative newcomers to the cosmic neighborhood, late arrivals to an ancient party. That means there have been billions and billions of years for other civilizations to arise somewhere out there, to grow and flourish, to spread across the galaxy, to make their presence unmistakably known to anyone who might be watching. If intelligent life had emerged even once in our galaxy's early history, they would have had enough time to explore and colonize every single star system multiple times over. They could have built vast networks of communication spanning the entire galaxy. They could have constructed monuments visible from neighboring star systems, great works of engineering that would be impossible to miss. Or they could have simply filled space with the radio chatter of a billion worlds in constant conversation with one another. So where is everyone? This question hangs in the cosmic silence like a gentle mystery, neither threatening nor particularly comforting, just beautifully, persistently there. It is a question that makes the night sky feel both more wonderful and more lonely at the same time, like standing alone in a vast cathedral. The universe is big, almost incomprehensibly so, but most of it might as well be painted on the inside of a distant dome for all the good it does us. Here is something both humbling and oddly comforting to think about. Almost everything beyond our local cluster of galaxies is drifting away from us, carried by the expansion of space itself, like boats drifting apart on a vast ocean, and we will never, ever be able to visit it, no matter how advanced our technology becomes. Even if we invented the most magnificent spaceships imaginable, vessels that could travel close to the speed of light and last for millions of years without breaking down, the distant galaxies would remain forever out of reach. By the time we could get there, they would be even farther away, like trying to catch a horizon that keeps retreating as you walk steadily toward it. So let us narrow our focus to something more manageable, more intimate, and closer to home. Our home galaxy, the Milky Way. The Milky Way is a spiral galaxy, shaped like a vast cosmic pinwheel, with graceful arms of stars sweeping out from a bright central bulge that glows with the light of billions of suns. If you could somehow see it from the outside, floating in the darkness of intergalactic space, it would look like a slow-motion firework frozen in time, or perhaps a gentle whirlpool made entirely of light. It is about 100,000 light-years across, which means that light itself, the fastest thing in the universe, takes 100,000 years to travel from one edge to the other. Our Sun sits about halfway out from the centre in what astronomers charmingly call the galactic suburbs. Not in the crowded, chaotic downtown where stars jostle for space and supermassive black holes lurk at the centre, but not in the empty outer reaches either. It is a quiet neighbourhood, cosmically speaking, the kind of place where planets can form and life can take its time figuring things out without too much cosmic drama or dangerous radiation. The Milky Way contains somewhere between 100 billion and 400 billion stars. That is a range so vast, it is like saying there are between 100 and 400 grains of sand on a beach, then realizing each grain is actually a blazing sun that could warm entire worlds. About 10% of those stars are similar to our own Sun, not too big and not too small, not too young and not too old, but just the right size and age to nurture planets steadily for billions of years. And here is where things get truly interesting. Recent discoveries from planet-hunting missions suggest that roughly 1 in 5 of those sun-like stars has an Earth-sized planet orbiting in its habitable zone. Let us pause and let that sink in for a moment. If only 1% of those potentially habitable worlds actually developed life at some point, we would still be talking about tens of millions of living worlds in our galaxy alone, each one a story waiting to be discovered. But the Milky Way is not just vast in space, it is also ancient in time. While our solar system is about 4.5 billion years old, the galaxy itself is roughly 13 billion years old, almost as old as the universe itself. That means there were star systems forming, planets cooling and solidifying, and opportunities for life emerging for billions of years before Earth even existed as more than a cloud of cosmic dust. Imagine the possibilities that represents for a moment. While our planet was still a formless collection of cosmic debris slowly gathering together, there could have been distant worlds where life had already taken its first tentative steps from simple chemistry to complex biology. By the time the first fish were swimming in Earth's ancient seas, other civilizations might have already been contemplating the stars and wondering if they were alone in the universe. Some of those early star systems had billions of years to work with, billions of years for life to emerge from the cosmic soup, to evolve and diversify, to become intelligent and self-aware, to develop technology and culture, and to spread across their corner of the galaxy like seeds carried on the cosmic wind. If even one of those ancient worlds had given rise to a spacefaring civilization, they would have had enough time to visit every star system in the galaxy multiple times over, leaving their mark wherever they went. Think about it this way. Human civilization has existed for only a few thousand years, barely a heartbeat in cosmic time. And already we have sent probes to the outer planets of our solar system, walked on the moon, and seriously discussed ambitious missions to Mars and beyond. If we survive another 1,000 years, another 10,000, another million, what might we accomplish? What might we build? How far might we spread across the galaxy? Now multiply that potential by billions of years, and you begin to understand the true scope of the mystery. The galaxy should be filled with the works and words of ancient civilizations, some perhaps so advanced that their technology would seem like pure magic to us. They might have reshaped entire solar systems to suit their needs, built vast networks of communication spanning thousands of light years, or simply filled space with the gentle background hum of a million worlds in constant conversation with one another. Yet when we look out into our galactic neighborhood with our best telescopes, when we listen with our most sensitive radio dishes turned toward the stars, we see and hear nothing obviously artificial, nothing clearly made by intelligence. The stars burn quietly in their ancient patterns, just as they have for billions of years. The planets orbit in their silent dance, following the laws of physics with perfect precision, and space itself seems utterly empty of voices calling across the void, reaching out to make contact. This silence from our cosmic neighbors has a name, the Fermi Paradox, named after the physicist Enrico Fermi, who reportedly asked this very question during a casual lunch conversation back in 1950. It is not really a paradox in the strict mathematical sense, but rather a profound puzzle about the nature of life, intelligence, technology, and our place in the universe. Have you ever tried to imagine a billion of anything? Most of us can picture 100 things fairly easily, maybe even 1,000 if we are feeling ambitious and patient. But a billion exists in that strange territory where numbers become too large to feel real, too vast to hold in your mind all at once. And yet when we talk about the possibility of life in the universe, billions are just the starting point for our calculations. Let us play with some numbers gently and without pressure. There is no test at the end of this, no quiz to pass. just the quiet pleasure of contemplating vastness and possibility. In our Milky Way galaxy, there are roughly 20 billion stars similar to our Sun. Not identical to it, mind you, but close enough in size, temperature, brightness, and lifespan to potentially nurture worlds like ours for billions of years. Now, of those 20 billion Sun-like stars, recent observations from space telescopes suggest that about 20% have Earth-sized planets orbiting in their habitable zones. That sweet spot where conditions might be just right for life. That gives us 4 billion potentially habitable worlds just in our galaxy alone. 4 billion opportunities for liquid water to pool on rocky surfaces, for atmospheres to develop and thicken, for the delicate chemistry of life to begin its ancient dance from simple to complex. But let us be conservative, wonderfully, absurdly conservative in our estimates. Let us say that only 1% of those worlds actually develop life at some point in their history. That still gives us 40 million living worlds, 40 million planets where something might be growing, breathing, swimming, crawling, flying, or perhaps even thinking and wondering about the universe. Even if we are off by a factor of 1,000 in our estimates, even if life is far rarer than we currently imagine based on what we know, we are still talking about tens of thousands of potentially living worlds scattered across the galaxy. And here is where the element of time enters the equation like a multiplier in a cosmic calculator, making everything even more mysterious. The Milky Way has been making stars and planets for about 13 billion years. Earth formed relatively recently in that timeline, only 4.5 billion years ago. That means the galaxy had 8.5 billion years to experiment with creating life before our planet even existed as anything more than a cloud of gas and dust slowly condensing. During those ancient eons stretching back into deep time, countless star systems formed, matured, and created the right conditions for life to emerge and flourish. Some of those systems had billions of years more time than we have had here on Earth. If we think of intelligence as a rare flower that occasionally blooms in the vast garden of the galaxy, then the universe has had billions of years for such flowers to bloom, grow tall, and spread their seeds across the cosmic landscape. Consider this carefully for a moment. Human civilization, from our earliest cave paintings to our space telescopes peering into the depths of the universe, spans only about 10,000 years. In cosmic terms, that is less than the blink of an eye, a fleeting moment. If another civilization somewhere had even a million-year head start on us, they would be as far ahead of us technologically and culturally as we are ahead of our Stone Age ancestors. If they had a billion-year head start, the gap would be almost incomprehensible to contemplate. Such advanced beings might have technologies that seem like pure magic to us. They might be able to reshape matter at the atomic level with ease, travel between stars as casually as we travel between cities, or communicate instantaneously across galactic distances using physics we have not discovered yet. They might have built enormous structures visible from thousands of light years away, or filled space with vast networks of artificial satellites and communication relays connecting millions of worlds. But here is the thing about large numbers. They can be deeply deceptive. Large numbers can make something seem inevitable and certain when it might actually be extraordinarily rare. Maybe the development of intelligent life requires such a precise sequence of events, such a delicate balance of conditions over billions of years, that even with billions of opportunities scattered across the galaxy, it is still vanishingly unlikely to occur. Or maybe intelligence itself is reasonably common throughout the universe, but long-lived, technologically advanced civilizations are not. Maybe there is something about the very nature of intelligence or technology or civilization itself that makes it difficult to survive for the millions or billions of years needed to spread across the galaxy and make your presence known. The Drake equation, formulated by the astronomer Frank Drake back in 1961, attempts to quantify these uncertainties in a systematic way. It breaks down the probability of finding extraterrestrial intelligence into several key factors: the rate of star formation in the galaxy, the fraction of stars that have planets orbiting them, the average number of habitable planets per star system, the fraction of habitable planets that actually develop life, the fraction of living worlds that develop intelligent life, the fraction of intelligent species that develop detectable technology, and finally, the length of time such civilizations remain detectable by broadcasting signals or building visible structures. When you multiply all these factors together carefully, you get a number that could be anything from 1, meaning just us alone in the galaxy, to millions, suggesting a galaxy absolutely teeming with diverse civilizations. The equation is less a tool for making precise calculations and more a framework for thinking clearly about the problem. It shows us both why the universe might be full of life and intelligence, and why we might not have found any evidence of it yet. Each factor in the equation represents what scientists call a filter, a barrier or challenge that must be overcome for intelligence to emerge and persist over time. Some filters might be relatively easy to pass through, like the initial development of simple microbial life. Others might be extraordinarily difficult, like the transition from single-celled organisms to complex multicellular life, or the development of technology advanced enough to be detected across interstellar distances without destroying its creators in the process. The numbers tell us clearly that something remarkable should be happening out there in the galaxy right now. Whether it is billions of worlds teeming with simple microbial life, thousands of planets hosting complex ecosystems with diverse species, or even just a handful of advanced civilizations building and exploring, the sheer scale of space and time suggests strongly that we should not be alone in the universe. And yet, despite all these compelling numbers, despite all these billions of opportunities, despite all this vast amount of time that has passed, the universe around us appears quiet, empty, and waiting. The numbers say one thing clearly, but the silence we observe says something else entirely. In that puzzling gap between our expectations and our observations lies one of the most profound mysteries of our time. Time has a peculiar way of making everything feel both more possible and more mysterious at the same time. When we think about the age of our galaxy, 13 billion years, we are dealing with a span so vast that human language barely has adequate words for it. But let us try to make it a bit more tangible and relatable, shall we? If the entire history of the Milky Way was somehow compressed into a single calendar year, Earth would not form until late September. Complex multicellular life would not appear until mid-December. Dinosaurs would not walk the Earth until the day after Christmas. Humans would not show up until the last few minutes of December 31st. All of recorded human history, from the first written words to the present moment, would flash by in the final few seconds before midnight strikes. It is both humbling and oddly comforting to realize just how young we are in cosmic terms, how recent our arrival on the stage. But what about all those months before September in our cosmic calendar? What was happening in the galaxy during its long spring and summer while Earth did not yet exist? Stars were being born in vast stellar nurseries. Planets were forming from disks of gas and dust. And the conditions for life were slowly, gradually improving as the universe matured and cooled from its violent beginning. In the galaxy's earliest days, things were quite chaotic and dangerous. Stars exploded regularly in spectacular supernovae, bathing nearby systems in deadly radiation that would sterilize any worlds unlucky enough to be close. Heavy elements, the essential stuff needed to build rocky planets and support complex chemistry, was still relatively scarce in the universe. It was not the best neighborhood for delicate things like life to get started and thrive, but after 1 billion or 2 billion years passed, the galaxy began to settle down into a more stable state. Stars became more stable and long-lived. Heavy elements became more common as generations of stars lived and died, and the first truly habitable worlds began to form in quieter corners of the galaxy. Some of these ancient star systems had something we did not have, something precious and irreplaceable: time. Vast, almost incomprehensible amounts of time to work with. Imagine a planet that formed when our galaxy was only 3 billion years old. Such a world would have had 10 billion years to work with, more than twice the age of our entire solar system, from formation to now. If life emerged there even once in all that time, it would have had 10 billion years to evolve from simple to complex, to become intelligent and self-aware, to create technology and culture, to spread across its home system and beyond into the wider galaxy. 10 billion years is long enough for evolution to work what we might consider miracles. On Earth, complex life went from simple, single cells to human beings in less than 4 billion years. What might 10 billion years of evolution produce? What astonishing forms of intelligence might emerge given such vast stretches of time? What technologies might develop over such timescales? What deep understanding of the universe might accumulate across countless generations? Such ancient civilizations, if they existed anywhere, would be as far beyond us in development as we are beyond the first simple bacteria that appeared in Earth's early oceans billions of years ago. They might have evolved beyond the need for physical bodies entirely, existing as pure information or energy flowing through the cosmos. They might have learned to manipulate matter and energy in ways we can barely begin to imagine. They might have spread not just across their home galaxy, but found ways to influence the very structure and nature of space-time itself. But here is something strange and worth considering carefully. Maybe they are still out there somewhere, but so incredibly advanced that we simply do not recognize their presence when we look. If you somehow showed a modern smartphone to someone from the Stone Age, they might not even recognize it as technology at all. It might just seem like a strange, flat rock to them, nothing special or remarkable. Could we be surrounded by the works and constructions of ancient civilizations without even knowing it? Maybe what we interpret as natural phenomena, like certain patterns in star formation or unusual distributions of matter, are actually the products of engineering so advanced it appears indistinguishable from nature itself to our primitive eyes. Maybe the regular patterns we observe in some star systems are not the result of natural processes at all, but the work of beings who learned long ago to garden and cultivate on a galactic scale. Maybe the seemingly empty spaces between galaxies are not empty at all, but filled with a kind of technology or presence we are simply not sophisticated enough to detect yet with our current instruments. Or perhaps the silence we observe is itself meaningful and intentional. Maybe advanced civilizations do exist throughout the galaxy, but they have learned through hard experience the value of discretion and caution. Maybe they have discovered that broadcasting your presence loudly across the galaxy is not always wise or safe. Maybe they have learned to be quiet, to observe rather than announce themselves, to watch younger civilizations like ours develop from a careful distance. There is something both lonely and wonderful about imagining these ancient watchers, beings who emerged from their home worlds billions of years ago and have been observing the galaxy's slow development ever since. They might have watched our own sun form from a collapsing cloud of gas and dust. They might have observed the very first life appearing in Earth's early oceans. They might be watching us right now as we take our first tentative steps toward becoming a spacefaring species, wondering if we will survive and thrive. But time cuts both ways, like a sword with two edges. The same vast spans that allow for the development of advanced civilizations also provide countless opportunities for disaster and extinction. Stars explode without warning, asteroids collide violently with planets, ice ages come and go with devastating effects, supervolcanoes erupt and fill the skies with ash, and species go extinct, often suddenly and completely. Maybe intelligence is actually quite common in the universe, but long-term survival is rare and difficult. Even if a civilization becomes advanced enough to spread across multiple star systems, they still face challenges we can barely begin to imagine. Galactic collisions that reshape entire regions of space, gamma-ray bursts from dying stars, the slow but inevitable death of their home star, the relentless expansion of the universe itself, pulling everything apart. Maybe the galaxy is filled not with thriving civilizations, but with the quiet ruins of those who came before us, archaeological sites on a cosmic scale waiting to be discovered. Or maybe time itself is part of the answer to the paradox. Maybe advanced civilizations do exist, but they operate on timescales so vast and slow that they appear almost static to us. Maybe they think in terms of millions or billions of years, making their movements and decisions so slowly and carefully that we simply do not notice them, like trying to observe the gradual growth of a mountain range or the slow drift of continents. In the deep time of the galaxy, anything becomes possible and everything becomes deeply mysterious. The silence we observe might be temporary, just the result of looking at one brief moment in a vast story that spans billions of years. We might be early to the cosmic party, or late, or right on time. The only thing we know for certain is that we are here now, participants in whatever vast story the galaxy is telling. Imagine for a moment a civilization that has had a full 1,000,000 years to perfect their technology, to explore the cosmos thoroughly, to understand the deepest mysteries of physics and biology. What would they be capable of accomplishing? What would they build and create? How would they live their daily lives? The question is both fascinating and utterly impossible to answer with any real certainty. But that does not stop it from being wonderfully fun to think about and contemplate. Astronomers often classify hypothetical advanced civilizations using something called the Kardashev scale, named after the Soviet astronomer Nikolai Kardashev, who proposed it. It is less a rigorous scientific theory than an interesting thought experiment, a way of imagining how civilizations might grow and develop their capabilities over vast spans of time. A Type 1 civilization would be able to harness and utilize all the energy available on their home planet efficiently. They might have networks of solar panels covering entire continents, capturing sunlight on a massive scale. They might have geothermal plants tapping deep into their planet's core to extract heat energy. Or perhaps they would have more exotic technologies we have not invented yet. Things we cannot even imagine. They would have complete control over their planet's weather systems, could prevent asteroid impacts before they happened, and would have explored every single corner of their world thoroughly. Currently, we humans rate about a 0.7 on this scale. We are getting there slowly but surely, advancing bit by bit. A Type 2 civilization would be able to harness the entire energy output of their home star, capturing nearly all the light and heat it produces. This might involve building something like a Dyson sphere, a theoretical megastructure that would surround their star like a shell and capture virtually all of its energy output. From a distance, such a system might look quite odd and unusual to our telescopes. like a star that dims and brightens in strange patterns that natural processes cannot explain, or one that emits light in unusual wavelengths that do not match what we expect from normal stellar physics. They might live in vast artificial habitats, orbiting their star in intricate patterns, each one larger than an entire planet, each one home to billions or even trillions of beings living in comfort and prosperity. A Type 3 civilization would control the energy of an entire galaxy, managing the output of billions of stars. This is where science fiction becomes so advanced it truly feels like magic or divine power. Such beings might be able to move stars around like chess pieces on a cosmic board. They might create and destroy planets at will. They might even manipulate the fundamental forces of nature itself, bending the rules of physics to their purposes. They might exist partially or entirely as information and energy, no longer tied to physical bodies or even physical matter as we understand it. But these neat classifications might miss the point entirely. Maybe truly advanced civilizations do not focus obsessively on gathering more and more energy, like cosmic hoarders. Maybe they discover ways to accomplish incredible things efficiently, using far less energy than we might expect. Maybe they learn to work with natural processes, rather than overwhelming them with brute force. Maybe they become gardeners rather than engineers, gently shaping their environment rather than dominating it completely. Such civilizations might be all around us right now, but so subtle and refined in their methods that we simply do not recognize their handiwork when we see it. Maybe what we think of as natural evolution and the development of life is actually being gently guided by intelligences so advanced we cannot distinguish their work from nature itself. Maybe the elegant laws of physics that allow life to exist at all are not happy accidents, but the products of engineering on scales we cannot even begin to comprehend. Or maybe advanced civilizations take a completely different path entirely. Maybe they turn inward rather than outward, using their technology to explore the infinite landscapes of consciousness and experience, rather than the finite expanses of physical space. Maybe they create vast virtual worlds more interesting and beautiful than anything in the physical universe could ever be. Maybe they spend their time thinking deep philosophical thoughts, creating impossible works of art, or simply enjoying states of being and awareness we cannot imagine from our current perspective. There is something both thrilling and terrifying about the possibility of encountering such beings. They would be to us as we are to ants, perhaps even more so given the vast gap in development. But unlike us with ants, they might have developed profound wisdom to match their enormous power. Maybe their advanced understanding of the universe includes a deep appreciation for the value and uniqueness of all life, no matter how simple or young it might be. Maybe they practice a kind of cosmic ethics we can barely comprehend, watching younger civilizations and protecting them, but not interfering directly, allowing them to develop and grow in their own time and in their own unique ways. Maybe they have learned through long experience that diversity of thought and experience is precious and irreplaceable, that each emerging civilization offers something unique and valuable to the cosmic conversation. On the other hand, maybe they have become so alien in their thinking and perception that we would be completely incomprehensible to each other even if we tried to communicate. Maybe intelligence, given enough time to develop and evolve naturally, eventually transforms into something beyond anything we would recognize as thought or consciousness. Maybe the silence we observe is not the absence of intelligence at all, but the presence of intelligence so incredibly advanced it no longer communicates in ways we can detect or understand with our primitive instruments. It is also quite possible that becoming a Type 2 or Type 3 civilization is incredibly difficult, that most intelligent species never make it that far in their development. Maybe there are barriers and challenges we have not encountered yet, problems that destroy or transform civilizations just as they are reaching confidently for the stars. Maybe the galaxy is quietly littered with the ruins of Type 1 civilizations that reached too far, too fast, that pushed beyond their capabilities before they were truly ready. But perhaps the most intriguing possibility is that advanced civilizations do exist throughout the galaxy, and they are waiting patiently. Waiting for us to reach a certain level of maturity and understanding, a certain wisdom about our place in the cosmos. Maybe there is a galactic community out there somewhere, and we are simply not ready to join it yet. Maybe we need to prove we can take care of our own planet first, before we are invited to help take care of the galaxy. Or maybe they are waiting for us to find them through our own efforts. Maybe the universe is designed as a kind of test where civilizations have to prove their worth by solving the puzzle of detection on their own. Maybe the silence is not empty at all, but full of messages and signals we simply have not learned to decode yet with our current technology and understanding. Whatever the truth might be, the possibility of such advanced civilizations existing somewhere out there in the cosmic dark adds a profound sense of wonder to every star we see twinkling in the night sky, every new planet we discover orbiting distant suns. Each point of light in the darkness might be home to intelligence so advanced it would seem godlike to us, yet perhaps still recognizably alive, still curious about the universe, still reaching out into the mystery of existence with something like the same wonder and excitement we feel when we look up at the stars and dream. Here is a thought that might make your next evening walk under the stars feel quite different. If we really wanted to, if we pooled all our resources and determination and worked together, we could probably colonize the entire Milky Way galaxy in about 2 million years. That might sound like an impossibly long time to our ears, but in cosmic terms it is barely a moment, hardly worth mentioning. It is the blink of an eye, a single page in the vast novel of galactic history that spans billions of years. The idea is not as far-fetched as it might seem at first. We already have most of the theoretical knowledge needed to build what are called generation ships, massive spacecraft that could sustain human populations for centuries or even millennia while traveling between the stars at sublight speeds. These would not be quick trips by any means. Even our fastest current spacecraft would take tens of thousands of years to reach even the nearest star to our sun. But given enough time, enough resources, and enough determination and cooperation, it could definitely be done. Here is how it might work in practice. Imagine building a spacecraft the size of a small city, complete with closed-loop life support systems, artificial gravity created by rotation, and everything needed to maintain a healthy population of perhaps 50,000 people for several hundred years or more. This ship would head toward a nearby star system, taking maybe 1,000 years or so to make the long journey through the darkness between stars. Once there, the colonists would establish a permanent settlement on a suitable planet or moon, build infrastructure and industry, and eventually construct new ships of their own to send to other star systems further out. Each new colony would become a launching point for further expansion into unexplored space. Instead of one ship heading to one destination, you would quickly have dozens of ships heading to dozens of destinations, spreading out like ripples. The process would spread naturally, like ripples in a still pond after you drop a stone, or like life itself does here on Earth, branching and growing and filling every available ecological niche it can reach. Even at this relatively slow pace, with individual journeys taking many centuries and settlement periods taking additional centuries to establish, the overall expansion would accelerate dramatically as more and more colonies joined the collective effort. It is exponential growth on a truly galactic scale, Within 2 million years, following this pattern, every star system in the entire galaxy could have been visited, explored thoroughly, and potentially settled by our descendants. 2 million years sounds like an eternity to us, but in the context of the galaxy's 13 billion year history, it is essentially nothing at all, barely noticeable. If intelligent life had emerged anywhere in the galaxy, even just 10 million years ago, they would have had time to colonize the entire galaxy 5 times over by now. If they had emerged 100 million years ago, they could have done it 50 times, filling and refilling the galaxy with their presence. This timeline makes the Fermi Paradox even more puzzling and mysterious than it already was. It is not just that we do not see obvious evidence of advanced alien civilizations when we look around us. It is that if such civilizations had ever existed anywhere in our galaxy at any point, they should have had plenty of time to spread everywhere by now, including here to our own solar system. They should have reached Earth millions of years before humans even existed, before multicellular life crawled out of the oceans. Maybe they did visit Earth long ago. Maybe our planet has been visited countless times by curious explorers from distant stars over the eons. Maybe they established bases here to study our world, observed our early life with scientific instruments, and eventually moved on to other systems. Maybe the signs of their presence have been completely erased by natural geological processes, buried deep under millions of years of accumulated sediment and stone and continental drift. Maybe they are still here somehow, watching quietly from a distance, so advanced that we simply do not recognize their presence when we look around. Or maybe the challenge of interstellar colonization is far greater than we currently imagine from our limited perspective. Maybe the distances between stars are simply too vast for practical travel. Maybe the hazards are too numerous and deadly. Maybe the energy requirements are too enormous for any civilization to sustain long term. Maybe most civilizations look at the stars with longing, but decide ultimately that it is not worth the enormous effort and risk. Maybe they find ways to be content and fulfilled with their home systems, creating rich, meaningful civilizations that never feel the compelling need to spread beyond their sun's warm and comfortable embrace. There are practical challenges we might not have fully considered yet. Interstellar space is not truly empty as we once thought. It is filled with dust particles, hydrogen gas, and various forms of radiation. A ship traveling at high speeds for thousands of years would face constant bombardment from microscopic particles that would gradually erode its hull and critical systems. Maintenance would be a never-ending challenge. The psychological challenges might be even greater and more difficult to solve. How do you maintain a coherent civilization and culture across multiple generations of space travel in confined conditions? How do you preserve knowledge, culture, traditions, and a sense of purpose across the vast emptiness between stars when no one alive remembers the home world they left behind? Maybe the answer lies in different approaches to spreading across the galaxy that we have not thought of yet. Instead of sending biological beings in physical ships, maybe advanced civilizations send information and data, beaming the patterns of their minds and cultures across space to distant stars where they can be reconstructed by automated systems. Maybe they send self-replicating robots that can build new colonies and manufacture new robots at each destination they reach. Maybe they find ways to travel that we have not imagined yet, techniques that make the galaxy feel small and manageable rather than impossibly vast and empty. Or maybe time itself is the real barrier to expansion. Maybe civilizations simply do not last long enough to complete such ambitious journeys. Maybe the social and technological challenges of maintaining a multi-star civilization spread across light years are simply too great for most species to overcome. Maybe species naturally fragment and evolve and change as they spread across the stars. becoming so different from their origins that they no longer think of themselves as part of the same unified civilization. There is also the interesting possibility that galactic colonization is happening right now, but so slowly and carefully that we simply do not notice it yet. Maybe advanced civilizations are methodical and patient, taking thousands of years to fully explore and understand each new system before moving on to the next one. Maybe they are like cosmic archaeologists, studying each world in careful detail, preserving its unique history, protecting any life they find before establishing any permanent presence. Maybe the galaxy is already divided into territories and zones of influence that we do not recognize, with different civilizations maintaining different regions, all so advanced and subtle in their activities that their borders and activities remain invisible to our primitive detection methods. Maybe we live in what amounts to a nature preserve, a protected area where young civilizations are allowed to develop naturally without interference from elder species. The mathematics of galactic colonization suggests strongly that someone should have done it by now. The silence we observe suggests that either no one has tried, or they have succeeded so completely and subtly that we cannot detect them with our current technology. Either possibility raises profound questions about the nature of intelligence, ambition, wisdom, and survival on cosmic scales. But perhaps the most intriguing possibility of all is that galactic colonization is underway right now, happening all around us at speeds and scales we are only beginning to understand. Maybe when we finally develop the right tools to look more carefully and know what to look for, we will discover that the galaxy is far from empty and silent. Maybe it is actually bustling with activity we are simply not advanced enough to recognize yet. Picture a lunch conversation that would change how we think about our place in the universe forever. It is summer in 1950 in Los Alamos, New Mexico. A group of physicists are eating lunch together, discussing casually the latest science fiction stories about flying saucers and supposed visitors from space. The conversation is light and pleasant, perhaps a bit skeptical, the kind of relaxed chat you might have over sandwiches on any ordinary afternoon. Then Enrico Fermi, one of the true giants of 20th century physics and a brilliant mind, asks a simple question that cuts through the casual speculation like a knife through butter. But where is everybody? It seems like such an innocent question, almost throwaway, the kind of thing you might wonder aloud while looking up at a starry sky on a clear night. But contained within those 4 simple words is one of the most profound puzzles in all of science and philosophy. If the universe should be teeming with life, if the galaxy should be filled with advanced civilizations, if space should be absolutely buzzing with signals and ships and unmistakable signs of intelligence, then why do we see none of it anywhere? The question becomes even more pointed and urgent when you consider everything we have learned in the decades since Fermi asked it over lunch. We now know that planets are incredibly common throughout the universe. We know that the basic ingredients for life are scattered liberally throughout space. We know that there has been plenty of time, billions of years, for intelligence to emerge somewhere and spread. By all reasonable estimates and calculations, we should not be alone at all. The universe should be anything but silent. This is what we now call the Fermi Paradox, though it is not really a paradox in the technical philosophical sense. It is more of a profound discrepancy between what we reasonably expect to find and what we actually observe when we look carefully. It is the cosmic equivalent of expecting to find a bustling city full of life, and instead discovering only empty streets and darkened windows with no signs of activity. The paradox has only become more perplexing as our knowledge has grown over time. When Fermi first asked his question, we knew of no planets beyond our own solar system at all. Now we have discovered thousands of them, with new worlds being found regularly by telescopes and space missions. When Fermi wondered about the possibility of life, we had no real idea how common the basic ingredients might be in space. Now we know that water, organic molecules, and energy sources exist throughout the galaxy in abundance. Every discovery that makes life seem more possible and likely also makes the silence more mysterious and troubling. Every new exoplanet found in a habitable zone, every new moon discovered with subsurface oceans of liquid water, every new detection of organic molecules in space should increase the odds that we will find evidence of life somewhere out there. Instead, each new discovery seems to deepen the mystery of why we have not found it yet, despite looking carefully. The paradox forces us to confront some uncomfortable possibilities about the nature of life and intelligence in the universe. Maybe we are truly alone after all, the only living things in a vast, sterile universe of lifeless rocks and gas. Maybe intelligence is so rare that it emerges only once in a galaxy, or perhaps only once in the entire observable universe. Maybe we are not just lucky to exist, but impossibly, incomprehensibly fortunate to be here at all. Or maybe intelligence is actually quite common throughout space, but long-lived, stable civilizations are not. Maybe the galaxy is filled with the quiet ruins of species that briefly achieved consciousness and technology before destroying themselves or falling victim to natural disasters. Maybe space is essentially a cosmic graveyard of failed experiments in awareness, each one lasting just long enough to wonder if they are alone before falling silent forever. The paradox also raises profound questions about the nature of truly advanced civilizations. Maybe they do exist out there, but they are so advanced that we simply do not recognize their presence when we observe their works. Maybe what we think of as empty space is actually filled with technologies we cannot detect, communications we cannot decipher, activities we cannot comprehend with our current understanding. Perhaps most unsettling is the possibility that there is something ahead of us in our development, some barrier or challenge or test that destroys or fundamentally transforms civilizations before they can spread across the galaxy. Maybe every species eventually faces a crucial test of wisdom and capability, and most fail that test. Maybe we are approaching such a test ourselves right now, some critical point of development where civilizations either transcend their limitations or destroy themselves completely. But the Fermi Paradox is not just about aliens and empty space and unanswered radio signals. It is fundamentally about us, about what it means to be conscious and curious in a universe that seems largely indifferent to our existence. It forces us to consider our responsibilities carefully, our potential as a species, our place in the vast scheme of cosmic history. If we truly are alone, then we bear an incredible responsibility that extends across space and time. We might be the universe's only attempt at understanding itself, its only chance to develop wisdom, compassion, and purpose. Every choice we make, every step we take toward or away from wisdom and survival might matter on a cosmic scale we can barely imagine. If we are not alone, if the galaxy does harbour other intelligences somewhere, then the paradox becomes a question about detection, communication, and eventual contact. Maybe we are simply not looking in the right places yet. Maybe we are not searching in the right ways. Maybe we are not looking for the right things with our current technology. Maybe the signs are there waiting patiently for us to become sophisticated enough to recognize them. Or maybe the silence itself is a kind of message, a cosmic test of our ingenuity and persistence. Maybe advanced civilizations do not reveal themselves easily to younger species until those species prove their worth somehow, demonstrate their wisdom, or reach a certain level of understanding about their place in the universe and their responsibilities. The beauty of the Fermi Paradox is that it does not have a clear, obvious answer, not yet anyway. It remains one of those wonderful scientific mysteries that opens more questions than it resolves, that makes us think deeply about existence, intelligence, consciousness, and the nature of reality itself. It is a question that makes every single star in the night sky feel both more mysterious and more meaningful at the same time. Whether we are alone or surrounded by hidden intelligences watching us, whether we are early or late to the cosmic party, whether we are destined for greatness or destruction, the paradox reminds us that we live in a universe full of wonder, possibility, and profound questions that may take us centuries or even millennia to answer fully. Life, when you really think about it carefully, is a series of increasingly unlikely events. Each step along the path, from simple chemistry to complex consciousness, represents a barrier or hurdle that most matter in the universe never crosses successfully. These barriers, which scientists call great filters, might help explain why the universe seems so quiet despite having so many opportunities for life to develop over billions of years. Maybe we have already passed the hardest tests and challenges. Maybe the very fact that we are here thinking and wondering about our place in the cosmos means we have overcome challenges so difficult that most potential life in the universe never makes it through successfully. It is a comforting thought in some ways, suggesting that the hardest part of becoming a spacefaring civilization might already be behind us. Consider the first great filter carefully, the emergence of life itself from non-living matter. We still do not fully understand how non-living chemistry first organized itself into something that could grow, reproduce, and evolve over time. It might have happened in warm, shallow tidal pools heated by the sun. It might have happened around deep-sea hydrothermal vents. Or it might even have happened in space itself before arriving on Earth. But wherever and however it happened, it required an incredibly precise dance of molecules, a coordination of chemistry that might be far rarer than we currently imagine based on our limited sample size of one. On Earth, this crucial transition seems to have happened relatively quickly in geological terms, within the first billion years of our planet's existence, after it cooled enough to have liquid water. But maybe we were extraordinarily lucky in ways we do not appreciate. Maybe most planets with the right basic conditions for life never quite get the chemistry to work properly. Maybe they remain forever on the edge of life, filled with complex organic molecules that never quite cross that crucial threshold into true biology. Then came the long leap from simple single-celled life to complex cells with nuclei and specialized internal structures. This transition, which biologists call the emergence of eukaryotic cells, took nearly 2 billion years on Earth. 2 billion years of what seems like evolutionary stagnation, with simple bacteria dominating the planet, while more complex forms of life remained just a distant possibility. When complex cells finally did emerge, they did so through an extraordinary and unlikely process. One cell literally swallowed another whole, but instead of digesting it for food, it learned to live with it in a mutually beneficial relationship. The structures we now call mitochondria, the powerhouses that fuel our cells with energy, were once free-living bacteria that became permanent residents inside other cells billions of years ago. This symbiosis between different organisms was so successful that virtually all complex life on Earth depends on it today. But symbiosis is a delicate process requiring precise coordination between different organisms with different genetic codes. Maybe most attempts at such partnerships fail and fall apart. Maybe the galaxy is filled with planets where simple life never learned to cooperate, never discovered the benefits of working together, and so remained forever simple and primitive. Another potentially great filter might be the development of multicellular life, organisms made of many cells working together. For billions of years here on Earth, our planet was dominated entirely by single cells, each one living independently and competing for resources. The transition to creatures made of many cells working together cooperatively required entirely new forms of organization, new ways of coordinating growth and function across multiple cells. It required some cells to sacrifice their individual reproductive potential for the good of the whole organism, a kind of biological altruism that might be extraordinarily rare in the universe. Even after multicellular life finally emerged on Earth, there was no guarantee of increasing complexity. For hundreds of millions of years, life remained relatively simple overall. Basic plants and algae. Simple animals without complex features. Nothing that would particularly impress a visitor from space looking for intelligence. The explosion of complex animal forms with shells and eyes and nervous systems did not happen until about 500 million years ago, nearly 4 billion years after life first began its long journey. Perhaps the greatest filter of all was the development of intelligence capable of technology and science. Despite billions of years of evolution, despite countless experiments in form and function, despite the emergence of everything from flowers to whales, only one species on Earth has developed the kind of intelligence that can contemplate the stars and build tools to explore them. Intelligence might be much rarer than we think or hope. It requires not just a large brain, which several species have, but the right kind of brain connected in exactly the right ways and supported by the right social structures. It requires curiosity about the world, the ability to imagine future possibilities that do not yet exist, and the capacity to work together cooperatively on projects that span many generations. These might be extraordinarily rare combinations of traits that rarely come together. Even on Earth, intelligence almost did not survive to the present day. Our species came remarkably close to extinction several times in our history, with global populations dropping to perhaps just a few thousand individuals during climate crises. A slightly different outcome in climate change, volcanic activity, or disease could have ended our story before it truly began. But we did survive those close calls. And more than that, we developed language to communicate complex ideas. We developed writing to preserve knowledge across generations. We developed science to understand the world systematically. And we developed technology to extend our capabilities. We learned to pass knowledge from one generation to the next, building on the discoveries of our ancestors, imagining futures we could work toward together. We developed agriculture, which allowed us to settle in one place. We built cities where ideas could be exchanged. And eventually, we created the tools to explore beyond our home planet, reaching for the stars. Maybe this entire sequence from the first self-replicating molecule to creatures capable of wondering about their place in the universe is so unlikely that it happens only once in a galaxy, or perhaps only once in the entire observable universe. Maybe we have won a cosmic lottery with odds so astronomical that we can barely comprehend our good fortune. If this is true, if we have already passed the great filters that eliminate most potential life in the universe, then our existence becomes even more precious and meaningful than we realize. We are not just lucky to be alive and conscious. We are impossibly, incomprehensibly fortunate to exist at all in this form. We are the universe's way of understanding itself, its only known attempt at consciousness and curiosity. This possibility places an enormous responsibility squarely on our shoulders. If intelligence is this rare, this precious, this unlikely, then our survival and flourishing becomes a matter of cosmic importance. Every choice we make about how to treat our planet, our species, and our future might echo across the galaxy for millions of years to come. But there is also something wonderfully hopeful about this idea. If we have already overcome the greatest challenges, if we have already passed through the filters that eliminate most life in the universe, then perhaps our future is brighter than we sometimes fear. Perhaps the hardest part of becoming a truly spacefaring civilization is already behind us, and ahead lies nothing but possibility, growth, and the slow, patient work of spreading life and intelligence throughout the galaxy. But what if we have it backwards? What if the silence of the galaxy is not because life is rare, but because something systematically eliminates it just as it reaches the cusp of greatness? What if there are barriers ahead of us, challenges so difficult that most civilizations fail to overcome them? It is a less comforting thought, but one definitely worth considering carefully as we look out at the empty sky. Maybe the galaxy has been filled many times over with civilizations like ours. Species that developed agriculture and built cities, discovered science and created technology, achieved space travel and dreamed of spreading among the stars. Maybe they built radio telescopes and wondered why they heard no voices calling across the void. Maybe they asked the same questions we are asking now, felt the same mixture of wonder and loneliness when they contemplated the cosmic silence around them. And maybe, just as they reached the point we are reaching now in our development, something went terribly wrong. It could be something obvious, something we can already see, looming on our own horizon, like a storm. Climate change that spirals out of control, nuclear weapons that eventually get used, environmental destruction that crosses irreversible tipping points, resource depletion that leads to collapse. Maybe most civilizations never learn to manage their own success, never develop the wisdom to match their growing power. Maybe the same intelligence and creativity that allows a species to reshape their world on a massive scale inevitably leads them to reshape it in ways that cannot sustain life in the long term. We can see how this might happen even now. As civilizations become more technologically powerful, they gain the ability to alter their environment on global scales. They burn fossil fuels that change their climate. They build weapons that can destroy their entire planet. They consume resources faster than nature can replenish them through natural cycles. Maybe the transition from a planetary species to a true spacefaring one is exactly when these pressures become most intense and most dangerous. Or maybe the filter is more subtle, something about the very nature of intelligence itself. Maybe advanced technology inevitably leads to social fragmentation, to the breakdown of the cooperation and shared purpose that allowed civilization to develop in the first place. Maybe species become so specialized, so dependent on complex, interconnected systems that they lose the resilience to survive major disruptions. There is another more speculative possibility that is both fascinating and terrifying to consider. Maybe there is something we have not discovered yet, some new technology or scientific principle that seems promising but turns out to be catastrophically dangerous. Maybe most civilizations discover it, try to use it, and accidentally destroy themselves in the process. We can imagine what this might look like. Maybe it is an energy source that seems clean and limitless, but creates unexpected instabilities. Maybe it is a form of artificial intelligence that seems helpful at first, but ultimately replaces or eliminates its creators. Maybe it is a method of faster-than-light travel that works perfectly until it does not, taking explorers and their home worlds with them into oblivion. The scary thing about this possibility is that we might not see it coming. The last words of every advanced civilization might be something like, "This new discovery will solve all our problems," followed by eternal silence. But maybe the filter is not technological at all. Maybe it is biological or psychological. Maybe intelligence itself contains the seeds of its own destruction. Maybe the same curiosity and ambition that drives a species to explore and create also drives them to take risks they should not take, to push boundaries they should not cross. Or maybe the filter is simply time itself. Maybe civilizations naturally have lifespans, like individual organisms do. Maybe they rise from humble beginnings, flourish for a while, and then naturally decline and fade away, not through any catastrophe, but simply through the accumulated weight of time and change and entropy. Maybe the galaxy is filled not with ruins, but with species that chose to stop expanding, to stop exploring, to settle into quiet contentment on their home worlds. There is also the possibility of external filters, challenges that come from outside a civilization rather than within. Maybe the galaxy is more dangerous than it appears to our limited observations. Maybe there are natural phenomena we do not understand yet, cosmic events that regularly sterilize large regions of space. Maybe supernova explosions, gamma-ray bursts from dying stars, or other stellar catastrophes make it nearly impossible for civilizations to survive long enough to spread among the stars. Or maybe there is something deliberate about the silence we observe. Maybe there are ancient civilizations out there, so advanced and powerful that they actively prevent younger species from spreading and growing. Maybe they see the emergence of new intelligence as a threat to be contained rather than a wonder to be celebrated. Maybe the galaxy is divided into territories with strict borders, with newcomers eliminated before they can establish themselves as potential rivals. The idea of predatory civilizations is particularly unsettling because it suggests that the very act of becoming detectable, of sending out radio signals or building visible structures, might be exactly what brings destruction. Maybe the smart civilizations are the quiet ones, the species that learn to stay hidden and undetectable until they are powerful enough to defend themselves. But perhaps the most troubling possibility is that there are multiple filters ahead of us, a gauntlet of challenges that become progressively more difficult as civilizations advance. Maybe the transition to space travel is just the first test in a long series, followed by others we cannot even imagine yet. Maybe each step toward becoming a truly galactic civilization requires overcoming new barriers, and the cumulative probability of success becomes vanishingly small. If this is true, then our current moment becomes incredibly important. We might be approaching the most crucial period in our species' entire history, the time when we either overcome the filters that have eliminated countless other civilizations or join them in the cosmic silence. But there is also something empowering about this perspective. If we know about these potential filters, if we can see them coming, maybe we can prepare for them. Maybe awareness is the key to survival. Maybe the species that make it through are the ones that take the long view, that think carefully about the consequences of their choices, that learn to balance progress with wisdom. The great filters ahead of us, whatever they might be, are not necessarily insurmountable. They are challenges to be met with intelligence, cooperation, and care. They are tests that we might actually be equipped to pass if we are thoughtful enough, wise enough, and lucky enough to recognize them in time. Have you ever had the feeling you were being watched? That subtle sense that eyes were upon you, even when you could not see anyone there? Maybe that feeling projected onto a cosmic scale is not entirely wrong. Maybe we are surrounded by intelligences so advanced, so careful, that they observe us without our knowledge, like researchers studying animals in their natural habitat. This idea has a name, the zoo hypothesis. It suggests that advanced alien civilizations do exist, but they have agreed among themselves to maintain a kind of cosmic preserve around developing species like ourselves. We are the animals in the zoo, living our lives naturally while being quietly observed by beings we cannot detect and would not understand if we could. It is not necessarily a sinister idea, despite how it might sound at first. Think about how we study wildlife here on Earth. We try to observe animals in their natural state, minimizing our impact so we can understand how they truly behave when they are not influenced by human presence. We create protected areas where endangered species can develop without interference. We establish ethical guidelines about when and how to intervene in natural processes. Maybe advanced civilizations have developed similar ethical frameworks on a galactic scale. Maybe they have learned that young intelligences need space to grow, time to make their own mistakes, freedom to develop their own unique perspectives on existence. Maybe interference, no matter how well-intentioned, ultimately harms more than it helps. This would explain the apparent emptiness of space around us. It is not that there is no one out there. It is that they have agreed to stay hidden until we reach some threshold of development, some level of maturity that qualifies us for contact. Maybe that threshold is technological, requiring us to develop faster than light travel or master nuclear fusion. Maybe it is social, requiring us to overcome war, inequality, and environmental destruction. Maybe it is philosophical, requiring us to develop a certain wisdom about our place in the cosmos. The zoo hypothesis would also explain why we do not see obvious signs of galactic engineering or massive alien civilizations. Maybe such things exist, but they are carefully concealed from species like us. Maybe the galaxy is crisscrossed with trade routes and communication networks that use technologies we cannot detect. Maybe there are vast cities orbiting distant stars, but they are shielded or camouflaged in ways that make them invisible to our primitive instruments. It is a humbling thought in many ways. It suggests that despite our technological progress, despite our scientific achievements, we are still essentially children in cosmic terms. We are the equivalent of a newly discovered tribe in the Amazon. Fascinating to anthropologists, but not yet ready for full integration into global civilization. But maybe that is not such a bad thing. Maybe being in the zoo means being protected, being given the chance to develop at our own pace without the pressure and potential contamination of contact with far more advanced beings. Maybe the galaxy's advanced civilizations have learned through experience that premature contact can be devastating for younger species. There are historical precedents here on Earth that are not encouraging. When technologically advanced civilizations have encountered less developed ones, the results have often been catastrophic for the less advanced groups. Diseases, cultural disruption, economic exploitation, loss of independence and identity. Maybe galactic civilizations have seen this pattern repeat itself countless times and have developed protocols to prevent it. The zoo hypothesis also suggests a kind of cosmic loneliness that is different from simple abandonment. We are not alone because there is no one else out there. We are alone because everyone else has agreed to leave us alone. It is the difference between being forgotten and being given space to grow. One is tragic, the other is almost kind. Of course, this raises questions about the ethics of such arrangements. Do developing civilizations have the right to know they are being observed? Is it morally acceptable to withhold contact indefinitely? What if a species never reaches the threshold for contact? What if they destroy themselves while the watchers simply observe? Maybe there are disagreements among the galactic community about these questions. Maybe some civilizations favor early contact and intervention, while others insist on strict non-interference. Maybe the silence we observe reflects not universal agreement, but ongoing debate about how to handle species like us. There is also the question of what the threshold for contact might be. Maybe it is not just about technology or social development. Maybe it is about awareness itself. Maybe the test is whether we can figure out that we are being watched, whether we can develop the sophistication to detect their presence despite their efforts to remain hidden. In this scenario, our search for extraterrestrial intelligence is not just scientific research. It is a kind of graduation exam. Maybe the moment we develop the tools and methods to detect advanced civilizations, despite their attempts at concealment, is the moment we demonstrate our readiness for contact. Or maybe the threshold is simpler and more fundamental. Maybe we need to prove we will not destroy ourselves. Maybe the galaxy is filled with the ruins of species who achieved great technological power but never learned wisdom to match it. Maybe the Watchers are waiting to see if we can survive our own success, if we can learn to live sustainably on our home planet before we are trusted with access to the larger galactic community. The zoo hypothesis offers a middle path between the loneliness of being truly alone and the fear of hostile aliens. It suggests a universe that is not empty but carefully managed. Not hostile, but thoughtfully cautious. It implies that someone out there cares about our development, even if they care enough to stay hidden. Whether or not it is true, the hypothesis encourages us to think about what kind of civilization we want to become. If we are being watched, what kind of example are we setting? If there is a test we need to pass, how can we prepare for it? If there is a threshold we need to reach, what steps can we take to get there? Maybe the real value of the zoo hypothesis is not in its truth or falsehood, but in the way it makes us think about our responsibilities, our potential, and our place in a universe that might be far more crowded and complex than the silence suggests. Sometimes the most profound answers are the simplest ones, even if they are not the ones we want to hear. Maybe the reason we do not see evidence of life throughout the galaxy is not because it is hidden or destroyed, but because it is genuinely, extraordinarily rare. Maybe Earth is not typical, but exceptional, a cosmic lottery winner in a universe where the odds of life are far lower than we have assumed. This idea, known as the rare Earth hypothesis, suggests that while simple life might be relatively common in the universe, complex life, especially intelligent life, requires such a precise combination of conditions that it is essentially unique. Maybe we are not just lucky to be here. Maybe we are impossibly, incomprehensibly fortunate. Consider what had to go right for us to exist. We needed a star of just the right size and age, burning steadily for billions of years without the dangerous flares or instabilities that characterize many stars. We needed to orbit at exactly the right distance, close enough for liquid water, but far enough to avoid being tidally locked or stripped of our atmosphere. But that is just the beginning. We needed a moon, and not just any moon, but one large enough to stabilize our planet's tilt and create the tides that may have been crucial for early life. We needed Jupiter, acting as a cosmic vacuum cleaner, sweeping up asteroids and comets that might otherwise have made Earth uninhabitable. We needed plate tectonics to recycle our atmosphere and regulate our climate over geological time. We needed the right kind of magnetic field to protect us from harmful radiation. We needed the right atmospheric composition, the right amount of water, the right distribution of continents and oceans. We needed ice ages that were not too severe and warm periods that were not too extreme. We needed thousands of factors to align in just the right way for billions of years. And even with all these advantages, the path from simple chemistry to complex intelligence was neither straight nor guaranteed. Life on Earth has faced multiple mass extinctions, events that wiped out the majority of species and could easily have ended the story entirely. We have survived supervolcano eruptions, asteroid impacts, ice ages, and dramatic changes in atmospheric composition. Maybe most planets do not have this combination of stability and dynamism. Maybe most worlds are either too stable, remaining locked in simple chemical cycles, or too chaotic, with conditions changing too rapidly for complex life to develop. Maybe the Goldilocks zone is not just about temperature, but about countless interacting factors, each of which must be just right for billions of years. The rare Earth hypothesis also suggests that intelligence itself might be far more unlikely than we assume. Despite billions of years of evolution on our planet, despite countless experiments in form and function, only one species has developed the kind of intelligence that can contemplate the cosmos and build tools to explore it. Intelligence requires not just large brains, but the right kind of social structures, the right kind of environment, the right kind of challenges. It needs predators to drive the evolution of cleverness, but not so many that intelligence becomes impossible. It needs social groups large enough to support complex communication and culture, but not so large that cooperation breaks down. Maybe the conditions that produced human intelligence were themselves extraordinarily rare. Maybe the specific combination of climate change, social pressure, and environmental challenges that drove our ancestors to develop language, tools, and abstract thinking happens only once in a galaxy, or perhaps only once in the entire observable universe. If this is true, then the silence we observe is not mysterious at all. It is exactly what we should expect from a universe where complex life is incredibly rare and intelligent life is rarer still. Maybe we are not looking at a puzzle that needs solving, but at a simple statistical reality. We are alone because the odds of being anything else are astronomically small. This possibility is both humbling and empowering. It suggests that we are not just another species on just another planet, but something genuinely unique and precious. We are the universe's only known attempt at consciousness, its only known way of understanding itself, its only known source of art, music, love, and wonder. If we truly are rare, then our existence takes on cosmic significance. Every choice we make about our planet's future, our species' survival, and our potential expansion into space becomes a matter of universal importance. We are not just responsible for our own well-being, but for the continued existence of life and intelligence in the cosmos. But the rare Earth hypothesis also suggests that we should not expect rescue, help, or guidance from advanced alien civilizations. If we face challenges like climate change, nuclear weapons, or environmental destruction, we will have to solve them ourselves. There is no galactic community waiting to welcome us, no ancient wisdom to guide us, no backup plan if we fail. This places an enormous responsibility on our shoulders, but it also suggests that we might be more capable than we realize. If we are here despite impossible odds, if we have survived and thrived despite countless challenges, maybe we have the resilience and intelligence needed to overcome whatever obstacles lie ahead. The rare Earth hypothesis does not necessarily mean we will always be alone. If we survive and spread among the stars, we might eventually encounter other rare intelligences scattered across the galaxy or the universe. Such meetings would be incredibly precious. Encounters between cosmic siblings who beat impossible odds to exist at all. Or maybe our expansion itself will seed the galaxy with intelligence and life. Maybe the universe is waiting for us to become the gardeners, to carry the spark of consciousness from star to star, to ensure that life and intelligence persist even if their natural occurrence is extraordinarily rare. Whether we are truly rare, or simply the first to emerge in our corner of the galaxy, the possibility reminds us that existence itself is a kind of miracle. The silence we observe might not be empty at all, but pregnant with possibility, waiting for us to fill it with our voices, our discoveries, and our dreams. In a universe where intelligence might be incredibly rare, every moment of consciousness becomes precious, every discovery becomes significant, and every act of creativity or compassion becomes a cosmic gift. If we are alone, then we are also irreplaceable, and that makes our story not lonely, but magnificent. There is something almost meditative about radio silence, about tuning into the frequencies where alien civilizations might broadcast their presence and hearing nothing but the gentle static of cosmic background radiation. For decades now, we have been listening to the universe, hoping to hear something, anything, that would tell us we are not alone. The search has been both methodical and hopeful. Radio telescopes around the world scan the sky systematically. Automated systems sift through vast amounts of data, looking for patterns that could not be natural, signals that could only come from intelligence. We have looked for narrowband transmissions, the kind that stars do not make naturally. We have searched for pulses and patterns, for the mathematical signatures that might indicate a deliberate message, and the universe has been politely, persistently quiet. It is not that we have not found anything interesting. Space is full of fascinating signals. Pulsars spin and beam radio waves across the galaxy like cosmic lighthouses. Quasars billions of light years away pump out enormous amounts of energy. The remnant radiation from the Big Bang itself whispers constantly in our instruments, a kind of cosmic background hum that tells the story of creation. But none of these signals show the characteristics we would expect from intelligence. They are either too regular, like pulsars, or too chaotic, like solar flares. They can be explained by natural processes, by the physics of stars and galaxies, and the fundamental forces of nature. What we have not found is anything that requires intelligence to explain. The silence is particularly puzzling when you consider how easy it would be for an advanced civilization to make itself known. A simple radio beacon broadcasting a mathematical sequence or a recognizable pattern would be detectable across thousands of light years, with technology not much more advanced than our own. If anyone out there wanted to be found, we should have found them by now. Maybe that is the key word, wanted. Maybe the galaxy is full of intelligence, but none of it wants to be detected by young, potentially dangerous species like ourselves. Maybe the smart civilizations are the quiet ones, the species that learned early that broadcasting your location across the galaxy is not always wise. There is a dark possibility hidden in the silence. Maybe the reason we do not hear from other civilizations is that they have all learned to be afraid. Maybe the galaxy contains predatory species, hunters who listen for radio signals and target any planet foolish enough to announce its presence. Maybe the universe is not empty but filled with hidden intelligences, all keeping quiet to avoid attracting the wrong kind of attention. This would explain not just the silence, but the apparent lack of larger-scale engineering projects, the absence of Dyson spheres, or other megastructures we might expect from advanced civilizations. Maybe building anything too obvious, too detectable, is an invitation to disaster. Maybe the successful civilizations are the ones that learn to develop sustainably and quietly, leaving no trace that could be detected from afar. Or maybe the silence tells us something about the nature of advanced intelligence itself. Maybe truly advanced civilizations do not need to communicate across space because they found better ways to share information. Maybe they have developed technologies that operate outside our understanding of physics, forms of communication that use quantum entanglement or dimensions we have not discovered yet. Maybe the radio spectrum, which seems so logical to us as a way to communicate across stellar distances, is actually a very primitive approach. Maybe trying to contact aliens with radio waves is like trying to reach someone across town by sending smoke signals when everyone else is using cell phones. There is also the possibility that advanced civilizations have simply moved beyond the need for electromagnetic communication. Maybe they have learned to encode information directly into the structure of space-time to communicate through gravitational waves or other phenomena we are only beginning to understand. Maybe the universe is actually buzzing with conversation, but we are listening to the wrong channels. Another interpretation of the silence is that it reflects the natural lifespan of detectable civilizations. Maybe species only broadcast for a brief period in their development, a few centuries or millennia, when they have radio technology, but have not yet developed more sophisticated methods. Maybe we are in our broadcasting phase right now, but we will eventually grow beyond it. If this is true, then the chances of two civilizations being in their radio broadcasting phases at the same time and being close enough to detect each other becomes vanishingly small. The galaxy might be full of intelligence, but they are all using communication methods we have not developed yet. But perhaps the most troubling interpretation of the silence is that it reflects the reality of the great filters we discussed earlier. Maybe we are not hearing from anyone because there is not anyone to hear from. Maybe the development of radio technology is often followed quickly by self-destruction, leaving behind silent worlds orbiting distant stars. The silence might be the universe's way of telling us something important about our own future. Maybe it is a warning that we need to be more careful, more thoughtful about how we develop and use our technology. Maybe the civilizations that survive are the ones that learn to listen before they broadcast, to understand before they announce themselves. Yet there is something beautiful about our persistence in the face of this silence. Despite decades of hearing nothing, we keep listening. Despite the vastness of space and the apparent emptiness of the radio spectrum, we maintain our search. There is something touching about humanity's refusal to accept that we might be alone. Our continued hope that somewhere out there, someone might be trying to reach us. The silence of space is not necessarily empty. It might be full of meaning we do not yet understand, full of signals we do not yet know how to detect, full of intelligences waiting for us to become sophisticated enough to join the conversation. Or maybe the silence is exactly what it seems, the sound of a universe where intelligence is so rare, so precious, so unlikely that it emerges only once in billions of years, in billions of star systems, leaving each conscious species to wonder if they are alone in the vast cosmic dark. Either way, the silence teaches us something important about ourselves, that consciousness is remarkable, that the universe's ability to understand itself through creatures like us is extraordinary, and that whether we are alone or surrounded by hidden intelligences, our existence is a kind of miracle worth protecting and celebrating. If we step back and look at all the possibilities we have explored, one thing becomes clear. Regardless of whether we are alone or surrounded by hidden civilizations, we carry an extraordinary responsibility. We might be the universe's only attempt at consciousness, or we might be one voice in a vast choir we have not learned to hear yet. Either way, what we do matters on a scale that is hard to comprehend. Think about it for a moment. If the rare Earth hypothesis is correct, if intelligence truly is extraordinarily uncommon, then we are not just another species on another planet. We are the universe's way of understanding itself, its only known source of art and music, love and laughter, curiosity and wonder. Every human who has ever lived, every thought that has ever been thought, every discovery that has ever been made, represents something unprecedented in the cosmos. That is a staggering responsibility. It means that our choices about the future, our decisions about how to treat our planet and each other, have consequences that stretch far beyond our immediate concerns. If we destroy ourselves through war, environmental damage, or simple carelessness, we might be extinguishing the only light of consciousness in an otherwise dark universe. But even if we are not alone, even if the galaxy is filled with hidden intelligences waiting for us to prove our worth, we still carry a unique burden. We are the only human civilization there will ever be. We are the only species that will ever see the universe through human eyes, feel wonder with human hearts, reach for the stars with human dreams and determination. Our perspective is irreplaceable. Even if 1,000 other species have gazed up at the night sky and felt the pull of cosmic mystery, none of them felt it quite the way we do. None of them expressed it through human language, human art, human science. None of them brought to the universe our particular combination of curiosity, creativity, and stubborn hope. This uniqueness extends to our potential as well. If we survive and spread among the stars, we will not just be adding another voice to the galactic conversation. We will be adding the human voice, with all its particular insights, perspectives, and ways of understanding existence. We will be bringing something genuinely new to the cosmic community, something that has never existed before and will never exist again. But our responsibility goes beyond just survival. It extends to how we choose to live, how we choose to grow, what kind of civilization we choose to become. If we are being watched by advanced beings, if we are being evaluated for readiness to join a galactic community, then every choice we make is a kind of test. How we treat our planet, our fellow species, and each other says something about what kind of neighbors we might be on a cosmic scale. How we respond to challenges like climate change, inequality, and conflict reveals our capacity for wisdom, cooperation, and long-term thinking. How we explore space, whether with humility or arrogance, with respect or exploitation, shows what we might bring to the galaxy. The responsibility is enormous, but it is also empowering. It suggests that individual choices matter, that what each of us does contributes to humanity's cosmic story. Every act of kindness, every moment of curiosity, every effort to understand and protect our world becomes part of our species' resume for galactic citizenship. Maybe this responsibility is exactly what we need. Maybe the awareness that we might be unique, that our existence might matter on a cosmic scale, is what will help us overcome the challenges ahead of us. Maybe understanding our potential cosmic significance will inspire us to be better than we sometimes are, to think more carefully about our choices, to work more cooperatively toward our common future. There is something beautiful about the idea that we are not just living our individual lives, but participating in a cosmic experiment in consciousness. Every human achievement, from the first stone tools to the latest space missions, represents part of the universe's attempt to understand itself. Every work of art, every scientific discovery, every moment of love or compassion adds something precious to the cosmic story. If we are alone, then we are also irreplaceable guardians of something infinitely valuable. The spark of awareness that allows the universe to know that it exists. If we are not alone, then we are still unique participants in the most extraordinary story ever told. The story of a universe that gave birth to consciousness and then watched that consciousness grow, explore, and reach back toward the stars from which it came. Either way, we are part of something magnificent. We are living at a moment when a single species on a small planet orbiting an ordinary star has developed the ability to ask fundamental questions about existence, to explore other worlds, to contemplate the possibility of life among the stars. We are witnesses to the universe waking up and beginning to understand itself. This perspective changes everything about how we might approach our future. Instead of thinking only about immediate needs and desires, we can think about our role in the cosmic story. Instead of focusing only on competition and conflict, we can focus on our shared responsibility as carriers of consciousness in a universe that might desperately need it. Whether we are alone or not, whether we are being watched or ignored, whether we are destined for greatness or extinction, we have the opportunity to be part of something extraordinary. We have the chance to be good ancestors to future generations, good stewards of our remarkable planet, and good representatives of consciousness itself in whatever cosmic community might exist. The universe has given us an extraordinary gift, the ability to wonder, to question, to explore, to love. Our responsibility is to use that gift wisely, to nurture it carefully, and to pass it on to whatever comes next, whether that is our own descendants spreading among the stars or other forms of consciousness we have not imagined yet. Perhaps the most wonderful thing about the Fermi Paradox is not that it might have an answer, but that it exists at all. Here we are, conscious beings on a small world orbiting an ordinary star, sophisticated enough to contemplate our place in the cosmos and to realize that we do not understand it nearly as well as we thought we did. The question, where is everybody, contains within it so many assumptions about intelligence, communication, technology, and the nature of existence itself. It assumes that life naturally tends toward complexity, that intelligence naturally tends toward expansion, that advanced civilizations naturally tend toward detectability. Maybe some or all of these assumptions are wrong, and the real answer lies in directions we have not thought to look yet. Maybe the universe is stranger than we can imagine. Maybe consciousness takes forms we would not recognize, exists at scales we have not considered, or operates according to principles we have not discovered. Maybe what we think of as the fundamental constants of existence, things like the speed of light and the arrow of time, are more flexible than we realize, opening up possibilities for communication and travel that currently seem impossible. Maybe the galaxy is filled with intelligence, but it is intelligence so alien to our way of thinking that we simply do not recognize it as such. Maybe some civilizations evolved from silicon-based chemistry and think in terms of geological timescales, their thoughts unfolding over millions of years like slow-motion continental drift. Maybe others exist as pure information, as patterns in electromagnetic fields or quantum fluctuations, thinking thoughts we cannot even imagine. Maybe some intelligences exist at the quantum level, consciousness that emerges from the strange behaviors of subatomic particles. Maybe others exist at cosmic scales, thinking thoughts that span light years and take millennia to complete. Maybe the universe is layered with consciousness at every level, from the quantum to the cosmic, and we are only aware of the narrow band that operates at our particular scale of space and time. The beauty of not knowing is that it keeps all possibilities open. As long as the universe seems quiet, we can imagine it filled with hidden wonders, secret civilizations, forms of life and intelligence that would astonish and delight us if we could encounter them. The silence preserves the mystery, maintains the sense that anything might be possible just beyond the reach of our current understanding. Maybe that is part of the point. Maybe the universe is designed to be mysterious, to always offer new questions just as we think we are beginning to find answers. Maybe the Fermi Paradox is just one note in a vast symphony of cosmic mysteries that will keep us curious and humble for as long as we exist. There is something deeply human about our response to this mystery. We do not just accept the silence, we make up stories about it. We imagine zookeepers and great filters, ancient watchers and cosmic gardeners. We populate the empty spaces with possibilities because we cannot bear to think of them as truly empty. We refuse to accept that we might be alone because loneliness, even cosmic loneliness, goes against something fundamental in our nature. This impulse to imagine, to speculate, to dream about possibilities beyond our current knowledge is one of the most beautiful things about human consciousness. We are not content to simply exist. We have to understand, to connect, to find meaning in the patterns we observe. Even when those patterns seem to tell us we are alone, we keep looking for evidence that we are not. Maybe this curiosity itself is the answer to the Fermi Paradox. Maybe the universe is quiet not because it is empty, but because it is waiting for us to develop the right questions, the right tools, the right perspectives to join the conversation that has been going on all around us. Maybe contact is not about them finding us or us finding them, but about us becoming the kind of beings who can participate in whatever cosmic community actually exists. The search for extraterrestrial intelligence changes us, even if we never find anything. It makes us think about what intelligence really means, what life really requires, what consciousness really represents. It forces us to examine our assumptions about the nature of existence and to remain open to possibilities we have not considered yet. Every time we point our telescopes at the sky, every time we send signals into space, every time we wonder about the possibility of life among the stars, we are doing something extraordinary. We are participating in the universe's attempt to understand itself. We are taking matter that was forged in the hearts of dying stars and using it to contemplate the possibility of other matter in other places becoming conscious and curious. Whether we ever make contact with alien intelligence or remain forever alone with our questions, the search itself is transformative. It connects us to something larger than ourselves, something that spans the cosmos and encompasses all of time. It reminds us that we are part of a story that began with the Big Bang and continues through every star that shines, every planet that forms, every moment of consciousness that emerges from the cosmic dance of matter and energy. The Fermi Paradox might never be solved, and maybe that is perfectly appropriate. Maybe the universe needs questions that do not have easy answers, mysteries that keep us reaching beyond our current understanding, puzzles that remind us how much we still have to learn. In the meantime, we have the gift of wonder, the privilege of curiosity, and the extraordinary opportunity to be conscious participants in the grandest story ever told. Whether we are alone or surrounded by hidden intelligences, whether we are destined for contact or eternal solitude, we are still part of something magnificent. A universe that gave birth to consciousness and then filled that consciousness with an irrepressible desire to understand and connect. The silence of space might be empty, or it might be pregnant with possibilities we cannot yet imagine. Either way, it is ours to contemplate, to question, and to fill with our own voices as we continue the ancient human tradition of looking up at the stars and wondering what might be looking back. As we drift toward the end of our cosmic journey tonight, perhaps it is worth pausing to consider what this grand mystery might mean for us, here and now, on our small blue world, spinning quietly through space. The Fermi Paradox is not just an abstract puzzle for scientists to solve in their laboratories. It is a mirror that reflects our deepest questions about existence, consciousness, and our place in the vast story of the universe. Whether we are alone or surrounded by hidden intelligences, whether we are early or late to the cosmic party, whether we face great filters ahead or have already passed them behind us, one thing remains constant. We are here now, conscious and curious, capable of asking these questions at all. That itself is extraordinary, perhaps even miraculous. Think about the chain of events that had to unfold for this moment to exist. Stars had to live and die to create the heavy elements in our bodies. Planets had to form and cool. Life had to emerge from simple chemistry and slowly, patiently develop complexity. Intelligence had to evolve. Consciousness had to dawn. And civilization had to develop to the point where creatures like us could contemplate the cosmos and wonder about our place within it. Every one of these steps was unlikely, perhaps extraordinarily so. Yet here we are, the products of billions of years of cosmic evolution, matter arranged in such intricate patterns that we can think about matter, energy organized in such complex ways that we can contemplate energy information processing systems sophisticated enough to process information about information processing. We are, in a very real sense, the universe waking up and becoming aware of itself. Through our eyes, the cosmos observes its own structure. Through our minds, it contemplates its own mysteries. Through our emotions, it experiences wonder, beauty, and love. We are not separate from the universe. We are the universe, expressing one of its most remarkable potentials. This perspective changes how we might think about the silence we observe. If consciousness is rare, if intelligence is precious, if awareness is the universe's most unlikely and extraordinary achievement, then every moment of curiosity, every instance of wonder, every question we ask about our cosmic neighbors becomes infinitely valuable. Maybe the answer to where is everybody is less important than the fact that we are here to ask it. Maybe the search for extraterrestrial intelligence is less about finding aliens and more about understanding ourselves, our potential, our responsibilities as conscious beings in a universe that might desperately need consciousness to give it meaning. The Fermi Paradox teaches us humility. It reminds us how much we do not know, how many assumptions we make about the nature of life and intelligence, how vast and strange the universe might be compared to our current understanding. It keeps us curious, humble, and open to possibilities we have not imagined yet. But it also teaches us about our potential significance. If we truly are rare, if consciousness is as unlikely as it sometimes seems, then we carry a responsibility that extends far beyond our immediate concerns. We are not just living our individual lives. We are serving as the universe's memory, its capacity for understanding, its ability to appreciate beauty and meaning. The paradox encourages us to think beyond our usual time scales and concerns. It connects our everyday choices to cosmic consequences, our local actions to universal significance. How we treat our planet, how we manage our technology, how we relate to each other, all become part of humanity's resume for whatever role we might play in the larger cosmic story. Whether we ever make contact with alien intelligence or remain forever alone with our questions, we are still participants in something extraordinary. We are part of the universe's ongoing experiment in consciousness, its attempt to understand itself through creatures who can think and feel and wonder. Every scientific discovery, every work of art, every moment of compassion or creativity adds something to this cosmic conversation. Every time we choose cooperation over conflict, sustainability over exploitation, wisdom over short-term gain, we are helping consciousness thrive in a universe that might not have many opportunities for it. The silence of space, whether empty or full of hidden meaning, reminds us that consciousness is not guaranteed. It is not automatic, not inevitable, not permanent. It is something that emerges under special conditions and can be lost through carelessness or catastrophe. It is something to be treasured, protected, and shared. Maybe that is the most important message of the Fermi Paradox. Not that we are alone or that we are not, but that we are here now, aware and wondering, capable of asking profound questions about existence itself. Maybe the universe does not need us to find aliens to justify our existence. Maybe it needs us to be thoroughly, completely, magnificently human, curious, creative, caring, and conscious. Whether the galaxy is full of intelligence or empty of everything but our own small light, we have the opportunity to be good ancestors, good stewards, good representatives of consciousness itself. We have the chance to ensure that the universe's experiment in awareness continues, grows, and spreads, whether through our own expansion among the stars or through other forms of consciousness we might help nurture. The great silence that surrounds us might be temporary or eternal, meaningful or empty, but our response to it, our refusal to accept loneliness without question, our determination to keep searching and wondering and reaching toward the stars, says something beautiful about what it means to be human. To be conscious, to be part of the universe's long journey toward understanding itself. In the end, Maybe the Fermi Paradox is not a problem to be solved, but a gift to be treasured. A question vast enough to make us think about our cosmic context, mysterious enough to keep us humble, and profound enough to remind us that consciousness, wherever and however it exists, is something worth celebrating, protecting, and sharing across the stars. And so we arrive at the end of our quiet journey through the cosmic silence, though perhaps the silence is not quite as empty as it seemed when we began. We have wandered through vast numbers and deep time, through possibilities both wonderful and troubling, through questions that might not have answers and mysteries that might be their own reward. The universe may be filled with hidden intelligences, or empty of everything but our own small spark of consciousness. We might be surrounded by watchers or alone with our questions. We might be approaching great challenges or have already passed them. But whatever the truth might be, we are here now, aware and wondering, part of something extraordinary and ongoing. Tonight, as you settle into sleep, perhaps you will carry with you a sense of our cosmic context, an awareness of the mystery that surrounds us, and a feeling of connection to the vast story of which we are all part. Whether we are alone or not, whether we are early or late to the cosmic conversation, we are participants in the universe's attempt to understand itself. And if you found any peace in these cosmic wanderings, if the mystery of the silence made you curious rather than lonely, if the questions helped you drift gently toward dreams of stars and possibilities, we would be honored if you follow us for more journeys through the mysteries of science. Thanks for joining us here at Sleepy Science Stories, where we explore the universe together, one gentle question at a time. Sleep well and dream of the vast and patient cosmos still unfolding its secrets among the stars.